Okay, so we're going to continue on what I call the units and conversion problems. Most of these were motivated from real life stuff, although I did not put them on the formal real life algebra handout. We did the $18 trillion debt at the beginning of video 1 last time just to motivate you of why even in real life we need to understand these types of problems. This next one was motivated when I had a daughter at JMU and she was dating a guy down at Virginia Tech, and it would take my daughter at least 2 hours, if not longer, to make the drive. And he proceeded to tell me one time that he always does it in an hour and 45 minutes. And I told him that he was a speed demon and he was going to get a ticket. And so then he was good-naturedly arguing with me. So let's see who was right. So the question is, how fast was he driving on average? Because I also know that you can't drive a steady speed on 81. There's always traffic or the trucks, which means he's going to have to slow down at some parts and thus go faster at other parts. So let's see what answer we get just from the on average. Let's assume it's 140 miles. Pause the video for a second and see if you can figure out how fast he must have been driving. Okay, speed of a car is miles per hour, right? So remember, these units are actually setting up the fraction for you. It reminds you better have miles on top, hours in the bottom. So he went 140 miles. Now, please make sure you know, don't write this, you are not putting 1.45 there, right? Because that's like less than an hour and a half. Remember, minutes is out of 60. I tried to keep this number easy. Hopefully you realize that 45 minutes is 3/4 of an hour. But what about if the number's not so nice, right? 45 minutes divided by 60 minutes gives you what decimal part of an hour? And that would be 0.75. So that's an alternative way, if the number is not so nice, to be able to figure out in hours what is the decimal. And this turns out to be 80 miles per hour. So I told him he was going to get a ticket because I know for a fact that he must have been going over 80 at some point, which also could be a reckless driving ticket. So we had a good-natured conversation about that. All right, let's do a second example. Oh, this one, I'm going to keep it to my actual life because I've driven up to Boston for conferences before. But this one was really motivated from, again, I had 4 daughters. Numerous times, a few of them would always drive down to Myrtle Beach for beach week. If you've ever been in that scenario and you're taking friends, or it could even be giving people rides to Northern Virginia from JMU. And the question is always, how much should I charge them for gas? When my kids were going to Myrtle, they did really want to split up the gas money perfectly, not just charge someone a random amount of money. So I seem to be the only one who was capable of figuring out how much approximately it cost in gas to get from point A to point B. Now, of course, you need to know about what car you're driving. My Corolla, of course, is more efficient, does not cost as much money as when I think one of the guys was taking a real cute red Jeep down there, like the real Jeeps. I guess it's the Wrangler or whatever. Gets terrible gas mileage, right? So you do need to know, of course, the distance, price of gas, and how many miles per gallon the car actually gets. One thing when we do this in the classroom, I usually will do a homework first, but a lot of students and people in general think they have to know how much gas their tank holds. That is completely irrelevant. How big your gas tank is only determines how often you're stopping, and then you could combine it with going to the bathroom, etc. But it actually turns out I have a van, a big conversion van that gets terrible gas mileage. They put a 35-gallon tank on that van. My Corolla, that gets amazing gas mileage, it's like a 13-gallon tank. So the cars or trucks, SUVs, that actually get worse gas mileage, the tanks are bigger. So it kind of all evens out as to how often you have to stop on a trip. But please know, the size of the gas tank is absolutely irrelevant. But let's get me to Boston. We're trying to keep the numbers a little bit easier, so I'm just going to round it. Boston's about 600 miles from my house. My car gets about 35 miles per gallon. If I was taking all highway, actually it'd probably get a little bit higher, but I figured I'll run into traffic and stuff, so I think that's a pretty good estimate for my car. Currently, gas is about $2.10 per gallon. It's been pretty cheap lately. How much does it cost me to drive to Boston? You're going to see throughout my handouts and problems, the idea of calculating how much does it cost in gas is really a theme of mine, because I really do believe that any person who drives a car should be able to calculate this. Okay, well, I have to go 600 miles, right? Now, the first spot that students get a little confused, the 35 miles per gallon. 35 miles per 1 gallon. That's the actual conversion unit, right? Now, whether you're going to use it like that or like that is what you're going to have to figure out. And that's why, well, earlier I called this whole topic the units. Keeping up with the units is absolutely critical. Because look here, I've got my 600 miles. If I write times 35 miles per 1 gallon, I'm up to miles squared over gallon. That doesn't make any sense, right? But look, if I do this conversion, look at what happens. Times 1 gallon gives me 35 miles. Then my miles cancel, because if you don't like that I didn't have a denominator, you could just put that over just 1 if you want, right? My miles cancel, so that makes sense. I now have the unit of gallon, but I didn't ask you how many gallons it's going to take me. I asked how much it's going to cost me. Here's the other conversion unit we need to look at. $2.10 per gallon. Now, I want to be able to cancel out gallons, so $2, let's do this. You can always write it and then just check your work. Yeah, I'm good. Look, the gallons are canceling, so the dollar sign is street level, it's in the numerator. Yeah, that's going to be right. I'm about to tell you how much money. So 600 times 210 divided by 35. And this just turned out to be a very nice number, $36 on the spot. Now, if I wanted to drive back home, that would be another $36 for a total of $72, but I just asked for a one-way. All right, now we're going to go shopping. There is a problem in the book that I think you should have already done. I'm going to do that one first. It was pretty short, and then we're going to make it just a little bit longer. A little bit of background of how this is very real life. Again, I had 4 daughters. They go shopping by themselves now, but when they were young, of course, I had to take them shopping. Can you imagine me and 4 daughters shopping in a store? I always taught them to go to the sale racks, like there's a rack, 30 or 40% off. Well, and of course they were various ages. So often they would then yell out, "Mom, how much is this going to cost? Mom, this shirt is this amount and it's 40% off. How much does this cost?" So I did try to, before we went into the stores, give them some idea of the quick way to determine that. It's a 2-step process if you have to figure out how much money is going to be taken off for the discount, and then you have to subtract. That's a 2-step process. So we're going to try to turn it into a 1-step process, and I was so pleased to see this problem actually in your book. Number 9 has a lot of different parts, but we're going to do part D. All right, the item they say is cost $D, whatever. They want an expression for the reduced price if the item is 30% off. Okay, so as I kind of just talked through a second ago, we know if we have the original price of the shirt, whatever it is, minus the discount, that will give us the new price, the reduced price, right? The sale price, what you're actually going to pay. All right, they said for us to use D as the variable, minus, well, 30% of D, that's what they're going to take off, right? 0.3D. Remember, just like we did with probability, percents always have to be turned into decimals. Now, this is begging to be reduced. This is what I'm saying. This is a 2-step process. And depending on the age of my daughters at the time, that was going to be so much more complicated. So think about it. You can factor out a D. Please make sure you understand there really is an invisible 1 sitting here in front of the D. So I'm going to factor out a D, 1 minus 0.3. And what is 1 minus? Well, and I factored out a D there, right? 0.3. So this is D times 0.7, or most people prefer to call it, of course, 0.7D. And this is what I taught my kids as early as I could, that if a shirt is 30% off, you're paying 70% of the price. Now, timesing by 0.7 wasn't that easy. I used to tell my kids, the shirt's about $30, just times it by 7. They were smart enough to know if that was going to be $210 or $21. So it worked for us. But this is the expression. It's a 1-step process. Instead of thinking about I have to take off 30% and then subtract, it's so much easier to think about it as I am paying 70% of the price. So then you can kind of multiply by 0.7. We all have calculators on our phones anyway, but a lot of times you can do that in your head, at least to get a pretty good estimate as to what you're paying. So I did this all the time, and this is sort of going to be another theme of a lot of my word problems, plus a lot of the word problems that your book asks you. You're really going to want to start to see it like that. All right, let's up this just a little bit, because unless it's those couple of days in Virginia where we don't have to pay taxes, that's not all you're paying. There is something called sales tax. So let's do a slightly longer problem. Okay, so, well, let me read this to you, but then again tell you the motivation. Let's say a shirt is 30% off. There is also 5% sales tax. In real life, it might be 5.5. It also depends on what county you're in. Down in Charleston, South Carolina, I believe their sales tax is 9%. What is an expression for the total cost you will pay in terms of the original price? Another real life story. Probably 10 years ago, 5 to 10 years ago, day after Christmas, I had a couple of my daughters shopping at Short Pump Mall in Richmond. And you can imagine day after Christmas, it's a madhouse. Everyone's returning and shopping, etc. This was, again, probably 10 years ago because it's when Abercrombie and Fitch was still there. Now, Abercrombie and Hollister are the exact same parent company. So on this day, we were in Hollister. One of my daughters had already picked out a sweatshirt, and she actually has that sweatshirt on her body because she was cold. That's an important part of this story. Then we get up to the line for the cashier. The line is so long, it is so hot, there's loud music, etc. So I'm losing my patience. Well, we get really close to the register, and we stop moving, and I can tell there's something going on. Turns out, on that day, for a 3-hour period, all of the computers and the registers for Abercrombie and Hollister had shut down across the country. So, I think they were just taking like cash and check, which was fine. The young people who were working the registers, they had gotten out the paper slips to be able to do everything by hand. And they also had an adding machine sort of calculator next to them. So I'm about 3 people from getting checked out. So the math teacher and me sort of took over, and I looked over the counter, and I see that they were, writing like the prices of the person in front of me, and they had added it up. So they had the subtotal. But then they just looked really confused. They were just kind of standing there. So I asked them, I said, well, what else do you need? They're like, well, there's sales tax. We don't know how to do that. I said, well, what is the tax rate? And they said 5%. They had no idea how to calculate 5% of that subtotal. So I actually reached my hand over and I actually showed them on the calculator to take the price of the merchandise times 0.05. That would give them the tax amount. Then they had to add that to the price of the clothing. Now they had the total price. They could take the cash or the check from the people. Reason why I got involved is because I had to check out. I could not steal the sweatshirt that my daughter had on, so I helped them figure it out. Just basics like that. If you want to be a cashier at a store, you have to understand in case all the registers go down. So that's the motivation behind this one also. In the past, this problem has confused some people in the classroom. So what I'm going to do is actually do it concretely first, and then we're going to do it what I call abstractly or using generic algebra, okay? Let's, just so we can get a feel for our numbers, make your life easy. It's always easy if you just start with $100, as this is just a pretend scenario. Let's pretend my shirt cost $100. Why 100? Because it turns out you could also think in percents. 100 is just a really nice number. Okay, 30% off. Well, 100 times 0.3, right? That's your discount. So we would take off the $30. So now we have our shirt, our $100 shirt now costs $70, right? So that's the new price, or the sale price, whatever you want to call it. Now we have to add in the tax. See this? We subtracted because we were getting a discount, but tax is an addition. How much? 5% of the $70. This turns out to be $3.50 you would pay in tax. You just calculate that out on your calculator. Make sure you're using 0.05 and not 0.5. You will pay a total of $73.50. And you can think about it. If you want, you go one step further. I paid $73.50. It was a $100 shirt, right? So the multiplier would be 0.735. I'm pointing this out because I'm about to do it abstractly, and you'll see why in just a second. But now, I don't know that I was spending 100. What about if someone spent 50 or 20 or 15? So we need to have an expression that relates to every person. That's what all these calculators are that you find on the internet. Calculators for like your mortgage payment or student loan. You can tell them how much student loan you have, the interest rate, they ask you the questions and then they spit out how much you're going to pay monthly. Someone has figured out the formulas. They've programmed, on a computer. They ask you for your specific information so then they can spit out the answer. See, this concrete only works for $100. We want to set up a formula so then anyone can use our formula with this scenario, right, to figure out what they're going to pay. All right, so we're going to I prefer X over any other letter, of course. So our shirt is X dollars. Now so this beginning part is just like we did earlier. We have to subtract off the discount, which would be 30% of the price. 1 minus 0.3, 1x minus 0.3x, we did that earlier, gives us our 0.7x. So that's our sale price. Now we discount, right? We subtract, but now we have to add in our tax. What are we adding in? 5% of, remember, of in mathematics means multiply, 5% of the sale price, and this relates to this right here, which 0.05 times 0.7, this is 0.035x. Okay, so just think about your coefficients. Every now and then I get a question on this, so let me make sure we're okay. 4x plus 5x equals 9x, right? We're just adding our coefficients. So 0.7 plus 0.035. That is the expression. So if you had picked out a $50 shirt, you could do 0.735 times 50. Picked out a $20 shirt, picked out a $100 shirt, 0.735 times 100. Lo and behold, gives you $73.50. So if looking at something concretely helps you develop the algebraic formula, I think it's a fantastic idea to do that, because that's all algebra is, moving away from the concrete example that only works for one specific example and makes it more generic that will work for all examples. We're going to do one more, staying on the shopping theme. So get my papers organized. This is doing the real life algebra handout, which I did put in this packet of notes. You will need that for other videos also. So if you printed it, don't lose it. We're going to do number 8. So this was really, well, let me give my title first. So this is the real life algebra. Sometimes I call that RLA handout. We're going to do number 8. This one was motivated, again, probably 7 or 8 years ago when there was still the sort of Black Friday shopping when stores weren't open on Thanksgiving. And a lot of times stores would offer you an even special deal on Black Friday if you came in before noon or something. So you can read it, but this one basically says on Black Friday, you're going to get 30% off, but you're going to get an extra 10% if you come in before noon or something. And we, of course, do have the 5% tax. So given how crazy it is on Black Friday, it would be really nice to have a formula written out. So then as you're picking up all of your merchandise, you'd be able to figure out exactly how much you're supposed to be charged when you get up to the register. I find it fascinating that your generation does not seem to check receipts. I cannot tell you how many times things have rung up wrong on me and I have to correct it because it's computers, right? So I find your generation is way too trusting when you go shopping. You should always have an idea about how much you're going to pay for something just to make sure it rings up right, that the sale price rang up right, etc. Okay, now I lost my train of thought. Oh, here's the other thing that I find that a lot of people do not understand. When a store gives you 30% off and then an extra 10% off, that is absolutely not 40% off. They don't add those two together. They're going to take the 30% off first, then they're going to take the 10%, then they're going to add the 5%. So you have to understand that just about retail and commerce and shopping. Okay, so we've done the first part numerous times now. Let's just call X my merchandise. All right, I picked out X amount, but I'm getting my 30% off. So I'm going to do this one more time, but at some point, you're probably going to see that I immediately just start writing it as 0.7x. I am paying 70% of the price. Okay, so that's my first discount. That's my first discount. Now they're going to take 10% off of that. 10% off of what? Off of that price. That's the sale price. So sometimes if you want to like kind of circle your little bubble, that's the sale price. Now I got sale price minus 10% of my sale price. You're perfectly allowed, one thing times one thing times one thing. You can move them around, right? Figure out what 0.1 times 0.7 is. Take that coefficient away from the 0.7, whatever it takes for you to make sure. Well, maybe I should do one more step. Let's factor out the x. Okay, so that's what I just kind of talked through, but maybe I should show that. That turns out to be 0.63. See, if they were going to give you 40% off, that means you would have been paying 60% of the price. No, you're not. You're paying 63% of the price. Let me say this in a slightly different way, because some of you might, be saying, oh, I would have done it this way. I wonder if that's okay. I was at 0.7x, right? And we were figuring out we needed to take 10% off. You are welcome to do what I've been talking about for the last 20 minutes. That means you're going to pay 90% of that price, right? which, lo and behold, gives you the 0.63x. So if you got the 0.63x doing it that way, that is better than good. That means you're really understanding what we're doing. Okay, that's my merchandise before tax. State of Virginia has to get their tax, right? So now, let me come over here, just what we did earlier. We have to figure out what 5% of 0.63x, because you're not paying x or 0.7x anymore. This is the price at the register. They're going to figure out 5% of what you owe them. You can factor out if you want. I'm trying to make a lot of connections here. If you want to view this as the bubble, I got one of those plus 0.05 of those, which gives me 1.05. Once you do all the multiplication, you get 0.6615x. Let me attempt to say a few words of why I keep showing it in so many different ways. See, when we had a discount, our numbers were getting smaller. We went from basically a coefficient of 1 to 0.7 to 0.63 because they were taking off discounts, right? That makes sense. But remember, tax is adding to it. If there's 5% tax, you are really paying 105% of the original price. And that's what I wanted to try to show you right here. There's that 105% of whatever you bought. But of course it has to be in decimal form. That's why this number is bigger than 1, because tax actually adds to what we have to pay, as opposed to discounts, which reduce what we have to pay. So basically, pick out how much you're buying, original price or whatever, times it by 0.6615, and that should be exactly what the register is asking you to pay. All right. I think we're going to end this video here. There are 6 little word problems from your book that if we were in the classroom, I would have you guys get in small groups and work on. And it just makes more sense to make an entire video of those together as opposed to doing a couple of them. So let me look at, just after this video, just a few more homework problems. After the next video, I'll give you much more. So continue to work on whatever you've been working on. If I lost you on any problems on this video, redo those. Also do the real life algebra, number 3 and number 9. I do have answer keys posted. All right, we'll see you soon.